Well, I'm Richard Weinberg from the USC School of Cinematic Arts, and we've set up a project that is telemicroscopy for teaching biology. And what we're doing is really opening up the micro world of microorganisms and other microscopic phenomena too small to be seen with the naked eye, bringing this into a STEM high school class. So we're starting with a system at USC where we've incorporated a digital cinema camera, usually developed to shoot Hollywood movies, incorporated that with a really high quality microscope so that marine microbiologists at USC can place the type of samples that they're working with, which are plankton toads on the Pacific Ocean, put those in the sample and then stream them live in high definition to a STEM high school, starting with one in Chattanooga, Tennessee. This allows students to see what's happening under the microscope 1,800 miles away. We've also set up a high definition video conference so the students who are 11th graders in high school can have a real meaningful conversation with USC faculty who are experts in marine biology. Students can ask questions, and the students at the high school are actually developing their own experiments. In this case, they're overlooking the Tennessee River. So they're getting samples from the Tennessee River, doing various types of enrichment. They'll be sending those samples to us via overnight delivery, and marine biologists like Professor Dave Karen at USC will be then looking at the samples of the students' experiments, along with his own, and telling the students, okay, here's what's happening in the micro world. And what we're finding is that students are really engaged in this new type of experience. Students may have looked at a microscope before, but it hasn't really been interesting to them. One of the students said, yeah, I've looked at a microscope, but the image is only this big, and we're bringing it to them in a high definition or ultra high definition screen form. And also the students can actually control our microscope across the continent. So if the students see something interesting on the microscope screen, they can move it to the center of the stage. They can change the microscope objectives to go from 10x to 20x, or they can change the brightness, adjust the microscope in different ways. So it really engages the students as being actual experimenters, interacting with research equipment that they can never get their hands on at the high school level, and also having really some intellectual stimulation and inspiration from university faculty who they otherwise couldn't have contact with. So I think that as we scale this project up to reach more classrooms, to engage more faculty, to have more sort of microscope transmitting stations, we'll be able to use the type of infrastructure that US Ignite and Genie and NSF have put together to allow various types of experimentation to take place. We'll be able to use this in a way that is actually helping to train the next generation of potential scientists, medical workers, and engineers in a way that hadn't been possible before the birth of digital cinema and before these networks came into being, and before organizations like US Ignite came into being to fund these types of experiments.